Hi and welcome back. We had a few videos on using SymPy for computational algebra, and in those videos we were only dealing with normal variables, polynomials in them, Grobner basis, polynomial division, monomial ordering, things like that. Some of you may need a bit further than that, working with differential algebra, where your variables are not only x, y, z, but also their derivatives with respect to some other parameters. Let's say x, y, z are all variables or functions of t time. So not only x, y, z, but you also have derivative of x with respect to t, maybe the second derivative with respect to t, so twice derivation. And then you need ranking, which is ordering x, y, z and their derivatives. You have a polynomial that its variables are x and its derivatives, y and its derivatives. You want to extract them out, and you want to cancel them doing some pseudo division, which are univariate polynomial division with respect to only one of your differential variables, not just x, but maybe x derivative with respect to t is one variable for you, and then you want to get rid of that in your differential polynomial. Now the question is it possible to do that with SymPy? Well, here we are going to give you some ingredients that you can use them and write the algorithm that you need yourself. So the first thing you need to have is derivative. Is there any symbolic derivative in SymPy? Yes, it is. So let's create a simple Python file. Let's say test.py, and I'm importing everything. As I said in several videos, I never do import everything in my own work, but here is just educational, something quick. So I'm putting star everything, so I don't need to name symbols, function, other things one by one here. But in my own work, I exactly import things that I need. It has some benefits. We don't need to talk about that right now. So I have x, y. I could put z as well, but let's keep things short, small, fast. So I have only two x and y variables, which I want them to be function of t. I'm going to do like this, but soon we will switch it different way. So this is what you usually do up to previous videos, assuming that you don't know how to do differential algebra things with SymPy. So you have these three variables now. I will put f0 x square plus 2 times x times y. That's a simple polynomial, still no derivative here. You can have the derivatives involved, for example, if I take derivative with respect to t. But I haven't declared or explicitly told SymPy and Python that x and y have relation with t. What would happen if I take derivative? So I would say, okay, one, diff. So diff is for taking derivation in SymPy. There are different ways to take derivative as well, but this is one way. So I want to take derivative of f0 with respect to variable t. Would that work? So let's print f1. I run Python file, and it works. No error message. However, it gives 0 because it thinks x and y are independent from t. Therefore, well, the derivative is 0. So what should I do? I should say x and y are function of t. The way to do it is to write it the same way you write the functions in mathematics. You put the round parentheses and put the variable inside. And it's correct. However, still there is a issue. But let's try things ourselves. Seeing the error messages are not bad, actually. Those are parts of learning. It says x, which is a symbol, cannot be called. So it thinks you're calling x as a function, either Python function or SymPy function, on some other things, which is not possible because the symbol, class, or type is not callable. Okay, so what should I do? I define t as a independent symbol, sure, but then x and y, I call them as function x and y function y. You have the name that you use to call it inside your program and the name that it will use to print that thing in the terminal. I chose the same, but there is no necessity that they be the same. In any case, now these are symbolic x and y, but not just symbol, they are function. I didn't say or explicitly mention that they are function of t, but here it says, okay, x is a function, t is a symbol, and x is a function of t. That will be fine. And I could even have another symbol here, s, and I call x as a function of two things, t and s. That would be also fine. So let's run this. The output is here. It says twice of xt times derivative of x with respect to t, which is right. The exponent comes here, and one unit reduced from the exponent, and derivative of x with respect to t comes there, so that's fine. And then plus 2 times, and this is a product, so it will be derivative of the first one times the second, and the first without derivative times derivative of the second, and plus between them, which you see here, x times derivative of y, y times derivative of x. So it works fine. Now it's fine. So if something is a function of something else and you want derivative from them, you need to declare them with function, not with symbols. So that's the start. You could also use the symbol function to declare x and y as function. How? So let me comment these two lines. Say x and y symbols, x space y, up to here is the same. Now the extra bit is that I say explicitly the class of these symbols thing function. That will do the same thing that we did here. So either you use the function or you use symbols with class equal function. We run this and we get the same output. There are several things we want to do. So we want to do divisions and maybe eliminating one differential variable from a system of differential equations and getting some invariants involving only some of the differential variables that we are interested, right? For that, we need to have all those things that we were doing for polynomials, being able to extract coefficient of something in the polynomial, degree of one of the variables in the polynomial, right? And here, in addition to degree and coefficient, we need to be able to count how many times derivative is taken, because derivative of x with respect to t one time is one differential algebra variable, and derivative of x with respect to t twice is another differential variable, and we want to order them. And the difference of these two is not the coefficient or the degree exponent, is the order of the derivation, right? So to start with, I'm going to ask the coefficient of maybe derivative of x with respect to t in this expression, to see that you have still access to whatever you had in the univariate polynomial or multivariate polynomial things in the differential expressions. So print from f1 coefficient of derivative of x with respect to t one time. You see here, so the first term has derivative of x with respect to t with coefficient 2x. You see 2x here. The second term doesn't have its derivative of y. The third one has derivative of x with coefficient 2y. So you see this. Now if I say coefficient of this one with degree 0, so the constant term, what would happen? It gives you the part that doesn't have derivative of x with respect to t. And if you wanted an expression that has derivative of x with respect to t of different degree, 3, 2, 1, you could explicitly say you want coefficient of this variable to power that thing, right? The degree, right? So print degree of f1 with respect to derivative is respect to t, which is 1. Well, that's clearly. You could have, instead of this, just xt. That's would be fine as well. Here in this case it doesn't make much difference because everything is degree 1 in that derivative. But if you ask degree of f with respect to function, not the derivative, then it will be a bit of problem. Okay, so that needs a solution. What about if I do the coefficient part? So I pick up this, put it here. Well, I have to comment this, otherwise it will not go to the next line. 1 coefficient of xt and the constant term. Would that also raise an error? And that one didn't raise an error. It says 0. So it means nothing in the expression is free of xt, which is not right, because this one doesn't have xt. It has xt inside the derivative, but it didn't understand that. Let me put 1. For the 1, it understands. It factor xt from these two terms. It gives the correct coefficient. But for the constant term, it doesn't understand that this one is free of xt. So there are several things that you need to be careful. Degree with respect to x will be a problem. Coefficient of xt when you want the constant term will be a problem, right? So those two remain as question for you until our next session. What other things we need? I told you we need the count of, or the order of the derivation. So let's say I extract the differential variables from this expression, which is xt, derivative of xt, and derivative of yt, and yt itself. And then I pick up one of those. var is derivative of x t respect to t, and I want to receive 1, the order of derivation. How can I get that? Well, I can say var dot variable count. I have a typo, it should be a. Well, it doesn't give you 1, it gives you a tuple of tuples, and each tuple is variable and its order of derivation. So you need to do some work here. You can say, well, go through them, pick up those that the first variable is the one that you want. Here everything is t, but well, in the scenario that you have s and t, or t1, t2, t3, right, independent parameters, and then add them. So there is a piece of work here. In this case, you could say the first one, and because there is only one tuple inside this set of tuples, list of tuples, collection of tuples, and then the second entry of that is the order. It should be 1 now. So there are things to be careful. This part, and now a bit of technicality. What about if I have something that is not a derivative? So let's say I have t itself. What would I get here? Well, let's first go without this. What will be the output of variable count? Error message, because x does not have variable count. Variable count is an attribute for derivative class. So again, you need to be careful. You need to write a function with an if statement. If var is an instance of derivative, then call this variable count and do blah blah. If not, return 0, because it's not a derivative. So yeah, so you need to be careful about this part. What else do you need? Extracting these x and their derivatives, right? One thing that you can use is, let's say from f1, I want to take atoms that are of the type function and derivative. I will put some link for the help page of all the commands and methods and attributes classes that I'm using in this session, so you can go and read the documentation. So you, for example, know what is atom. What to be precise here, the expression that we have, for example, here, it will look through it, and anything that is an instance of function or instance of derivative, it will return back to you inside a list, I guess. Let's run this, where I put inside the set. So derivative of y with respect to t, xt, derivative of x with respect to t, and yt. And then you can go through the function that is putting order between these things and find the leading one, or whatever you want to do. Now, in this example, it's fine. We have 4 differential variables and it gives all of them. But what if my let's define different expression. I put xt square minus 5 times derivative derivative of x t with respect to t twice times x t plus derivative of y t with respect to t minus 1. So what is the difference of this one with previous of 1 is that I have xt, I have derivative of xt, I have derivative of yt, but I don't have yt itself. So what I expect is to receive same set but without yt, right? So here I have 2. I run this. I got derivative of y, okay. I got y, which is extra, derivative of x twice, okay, fine, xt is fine. But this one is extra. Where is this coming from? It's not a variable in our differential expression. The problem is at home is doing too much recursive calls. So when it is reading this derivative y, it put it here, but it also goes inside the derivative. It says, okay, y is also an instance of a function, so I put it in the output. But I don't want things that are inside derivative. So xt is a differential variable for me. This guy is a differential variable for me. This one is 1, and I'm not going inside that. So that's an extra thing coming out of atom. So atom is not the solution for us. I need to define function myself. Let's say differential variable character. I receive an expression, okay, and then what I want to do is to go through that. Maybe it's better that before going through this function, I give you something that is important. So let's say I have an expression of xt plus yt. For any expression, I can ask arguments. So I will tell you in a moment what it means. Every expression or every symbolic thing in SymPy, usually Python, are stored in a 3 data structure with a root. And the root is the first operation. So this is this guy plus this guy. So the root is plus. The children of this root are xt, yt, and then the function will have a function name x and function argument t. It's always also good to go look at the documentation of these things, how they define in the source file, and then you get these kinds of information which help you later. So for this one, the arguments will be this and this. And if I have more things, plus let's say derivative of x respect to t, plus is at the root, and then the arguments will be 3 things. Okay, so let's bring this. See, it's a tuple, derivative of x respect to t, x, and yt. There are the 3 children of plus for this expression, right? So I'm going to use these inside my function. my expression can be a single derivative, right? If that's the case, I will pick up that as single variable and that's done. If not, I will look at the arguments and go through each of them and look at them if they are function or derivative, so on. So first of all, I need an output list. Output is nothing if the expression is an instance of derivative, so, and derivative is a class, so is instance of derivative. What do I want to do? Output append expression. I will not go through whatever is inside. I will put it there, it's done. I'll go inside if it is not, else, and function as well. I don't want to go inside the function to look at maybe that function is function of something inside. One level is fine for my application. So is instance, say function, we put there. If not, then it's maybe a plus, a product, exponentiation, subtraction, whatever. And I'm in the differential algebra, I don't put other than non-negative integers in the exponents. So I assume everything is in the beautiful shape of my application. Of course, you can put some error catching things later in your finalized project so that you make sure the user is giving correct input and also write good documentation for your functions. Anyway, so the whole expression is not one derivative or one function. What I will do, I call a recursion and say for arg in expression args, same as here. That will be a tuple of things, and each of them I call arg output extend with the outcome of diff var extractor on arg. So it goes through each argument, extract things from them, bring them, send them back to this call, and append to these things. End of for loop, the end of if statement, return output. Now let's hope I don't have any mistake, and I do the same thing here. But this time, say diff var extractor of f2, and I expect to see only 3 white should not appear there, right? It will be in a list case. Now, one thing I'm worried is that I'm using list, and in the list repetition is permitted, so maybe it would be good if I was defining a set object to remove the repeated things. But in this case, I don't think we will end up with repetition, or do we? F2 has xt 2 times, so we may have xt 2 times. Later you can remove the repetition or change these things, but in any case, let me do like this for now. So I got xt derivative, xt again, and derivative y. So I fixed one problem, but I introduced another problem. It's easy to fix that. A very plain way, a simplest scenario that you can do is this one is empty, so it will add there. There is no need to worry about repetition. However, here I can do it this way. Say temp for temporarily put everything that is output of the next call here for let's say var in temp if not var in output, then output append with var. Okay, it's not maybe it's not the most optimized way to do it, but that's an easy thing. So xt, the derivative of y, and xt is not repeated again. So you need to use some of your creativity and skills that you learned. I'm going to end here, and hopefully you can use all the ingredients that we went through them to write a function of your interest to do some computation related to differential algebra. Oh, I will do one more thing. And also remember that you need to think about problems of coefficient of constant coefficient with respect to a function and degree with respect to a function. These two, I will leave it to you. If you couldn't solve it, you will see in next video probably. One other thing I want to show you is that you still can use the univariate polynomial division. So let's say I want to print division of f1. f1 was that derivative thing that we had before, and I have let's say another differential polynomial that has derivative of y. Using that, I want to find an invariant in the system of these two differential equations that does not have derivative with respect to y. So the second polynomial that I'm writing is derivative, just a random thing, y respect to t. Let's say it's yt square plus 1, and the derivative with respect to derivative t. So this is the variable of this univariate polynomial division. So this was f1, right? We have the derivative of y appearing here, and if the division works fine, wherever I have this, it should be replaced by y squared minus 1, right? So the first term is, okay, so the division in SymPy returns first the quotient and then returns the remainder. So it's a tuple, and then the remainder is this. 2x, the derivative of x is here, and then 2y, the derivative of x is here. Now here it will be 2x times y squared minus 1, so I will have 2xy squared and minus 2x. So the derivative worked fine. But test for yourself for whatever purpose that you want, and let me know if you wrote your favorite algorithm in differential algebra successfully using these things or not.